Early 1945, in the cold gray waters off Japan's coast, an American F4U Corsair went down after an engine failure during combat operations. The pilot ejected just before the fighter struck the Pacific, and within hours, Japanese patrol boats converged on the wreck. What they pulled from the sea was no ordinary prize. It was a fully intact Corsair, one of the most advanced aircraft of the war. For the Japanese, this wasn't just wreckage. It was a priceless window into American aviation engineering. For nearly 3 years, Japanese pilots had battled the Corsair across the Solomon Islands, Rabaul, the Philippines, and now near their home islands. They had come to respect its speed, its firepower, and its near-indestructible build. But never before had they been able to study one up close. Now, with an intact Corsair in their possession, Japan's aviation experts would come face to face with the full magnitude of American industrial and technological superiority, a realization that would shake their faith in their own capabilities. The Corsair represented the pinnacle of American fighter design. Our T.O., machine born from bold ideas and industrial power. Conceived in 1938 to meet the Navy's demand for a fighter exceeding 400 miles per hour, the F4U became a technological marvel. Chief designer Rex Basel and his team at Chance Vought built the aircraft around the massive Pratt Whitney R-2800 double Wasp engine, an 18-cylinder powerhouse generating over 2,000 horsepower. Its immense propeller forced engineers to innovate, leading to the Corsair's distinctive inverted gullwing, a design that allowed shorter landing gear, greater propeller clearance, and aerodynamic efficiency. When the prototype first flew in 1940, it became the first single-engine American fighter to exceed 400 mph, an achievement that stunned the aviation world. By late 1942, the Corsair entered service, and by 1943, it was battling over Guadalcanal. Its combat debut was rough. During the infamous St. Valentine's Day Massacre, American aircraft, including new Corsairs, suffered heavy losses against Japanese Zero fighters. But pilots quickly adapted, learning that the Corsair's advantage wasn't in turning battles but in speed and dive tactics, using boom and zoom maneuvers, diving from altitude, striking fast, and using power to escape. They turned the tide. By 1944, Marine pilots were mastering these tactics, and aces like Kenneth Walsh began racking up victories, proving the Corsair's lethality. Its 650 caliber machine guns, each precisely installed in the wings, delivered devastating firepower. As the war progressed, the Corsair evolved into a formidable fighter bomber, carrying rockets, bombs, and napalm in the Pacific campaigns. By the Okinawa invasion in 1945, the Corsair had become known to ground troops as the Angel of Okinawa. But what Japanese pilots saw in combat was only part of the story. When engineers at the Yokosuka Naval Air Technical Arsenal received the captured Corsair, they prepared for one of the most important examinations of the war. The aircraft's airframe, though damaged by salt water, was remarkably intact. Technicians began by photographing and measuring every inch of it. 40 feet 11 inches of wingspan, 33 feet in length, and its signature gullwing shape. They were struck by both its sophistication and practicality. They noted with surprise that parts of the wings and control surfaces were still fabric-covered rather than metal, a weight-saving choice that reflected deliberate, resource-conscious design rather than outdated construction. Inside the wings, Japanese engineers found aluminum forgings of extraordinary quality, components that their own factories could not match. The precision of every rib, spar, and fastener demonstrated an industrial discipline beyond Japan's capabilities in 1945. Even the Corsair's guns impressed them. The 6 Browning AN-M 2.50 caliber machine guns were marvels of reliability, supported by an ammunition feed system that worked flawlessly. The The Japanese examiners realized their own armaments, often hand-fitted and inconsistent, simply could not compete. Then came the cockpit and armor. Behind the pilot's seat, they found 150 pounds of armor plating and a 1.5-inch bulletproof glass shield. Japanese aircraft had largely abandoned armor to save weight, a choice once justified by the Zero's early successes. But the Corsair showed that with sufficient engine power, protection and performance could coexist. This realization underscored America's deeper advantage: power through technology. At the heart of that power was the Pratt Whitney R-2800 double Wasp engine. When Japanese engineers dismantled it, they were stunned by its precision. Every cylinder, piston, and bearing was machined to microscopic tolerances. The two-stage supercharger, vital for maintaining power at altitude, revealed a complexity and craftsmanship they could not replicate. Japan's attempts at similar engines had faltered, limited by materials and manufacturing precision. American engines could run at full power for hundreds of hours. Japanese engines often struggled to reach their rated performance before failure. Every part of the Corsair told the same story. Its Hamilton standard propeller was a masterpiece of hydraulic control. Its landing gear retracted smoothly, with parts machined to near-perfect symmetry. Its electrical systems were carefully routed and insulated. Even the wiring and fuel lines reflected attention to detail and access. The Corsair was built to last, an industrial product of a nation that could mass-produce perfection. By contrast, Japan's factories in 1945 were under siege, bombed, short on materials, and manned by overworked or undertrained labor. Aluminum quality had plummeted, and engines failed frequently. When the Yokosuka engineers completed their report, their tone was analytical but sober. They had measured every rivet, recorded every alloy, and documented every system. Yet what they found was more than data. It was the embodiment of an industrial power they could not hope to match. By war's end, at least 2 Corsairs had been captured and examined, with some evidence suggesting attempts to repair and test fly one. But Japan's defeat came before those efforts could yield results. When American forces arrived at Yokosuka in September 1945, they found the captured aircraft, along with extensive technical notes and diagrams, evidence of Japan's intense effort to understand American engineering. Those reports, now stored in archives, stand as quiet testimony to the moment Japan realized just how far behind it had fallen. The Corsair's wartime record spoke for itself. It achieved an astonishing 11-to-1 kill ratio over Japanese aircraft, with 2,140 kills for only 189 losses. Yet, those numbers only hinted at the larger truth: that America's victory came not just from better planes, but from a system that produced them in overwhelming numbers, with unmatched quality, logistics, and training. For Japanese engineers, the Corsair was both a revelation and a reckoning, proof that courage and skill could not overcome industrial and technological dominance. The F4U Corsair continued to serve long after the war, in Korea, in French colonial wars, and even in Central America, where in 1969, 2 Corsairs battled each other for the last time. It remains one of aviation's most successful designs, its legacy enduring nearly 30 years after its first flight. For Japan, the captured Corsair became more than a war relic. It was a mirror held up to their ambitions, showing both what they had achieved and what they could not. The lessons learned from studying it would echo through Japan's post-war rebirth. The emphasis on precision, quality, and continuous improvement that defined Japan's industrial rise in the decades after 1945 can trace its roots to lessons learned in those final desperate months, when Japanese engineers, examining the wreckage of an enemy fighter, confronted the hard truth of industrial modernity. The Corsair they studied has long since disappeared, likely scrapped amid post-war chaos. But its legacy endures, a silent testament to what technology, when powered by vast resources and relentless refinement, can achieve. In 1945, that Corsair spoke to Japan not in words, but in the language of metal, precision, and power. A language that would forever change how Japan built its future.